Hi, and welcome to my presentation on the art of subtraction. I believe this topic is the very core reason why systems succeed or fail. And I'd like to inspire software architects, but especially the young aspiring engineers who want to become architects. A little bit more about me. I am the founder of a company called Filtered Code. Currently, I am a contract software architect at a company called Code. And I also am a director at a company called Grow Strong, which is a non-profit organization. If you want to reach out to me, feel free to reach out to me on LinkedIn. Intro's out the way. Let's get into it. Picture this. Your marketing's paid off. You've got your website going. You've paid some boosts. And a new client comes to your door. This client is Bob. Now, Bob is a CEO of a growing SME. There's a lot of potential in his company. But Bob is angry. He's not angry with you. He doesn't know you yet. He's angry with the system that he has. He shares a little bit about the system. One of the things he says is, and you will never believe it, they're even still using a monolith. Even I, who's not technical, know that's a bad idea these days. One time, they were fixing something on the About Us. I mean, there's this tiny little piece in the corner and they broke the customer edit screen. How do you even touch the customer edit screen changing an About Us? He goes on with the horror stories and he tells you the one day they did half a day's worth of work that was lost because some job that was supposed to run in the night and process the data didn't run. Nobody knew. It just silently failed and didn't do what it needed to do. And they only discovered it halfway through the day and they had to revert all that work they did. And you know what else? He says to you, this business is my business. I have all the data and I don't know what to do with it. When I ask for a report, it takes them 3 weeks to create me a report. 3 weeks. And then I look at the data and I need a new question answered. There's another 3 weeks. Now, how do I enable my business when it takes me 3 weeks every time I have a question about my data? I want analytics into my own data. Surely a system should give me that. So you ask Bob, can I do an audit on your code? And he says, go for it. And so you start looking through the code and you see older framework is being used, some older packages. There are no unit tests. You notice that everything is server-rendered HTML. You find that some of the logging is just suppressed. There's no logs written when the errors happen, and other times it is written to a log file. You go to Bob and you say, Bob, would it be okay if we do a rewrite? A full-on new system rewrite. And he's like, sure. And you ask him that question that gets him going, that gets that dopamine spike. And you say, what would you like the system to be? Now, Bob, he's an entrepreneur, a visionary, like so many other CEOs out there. I want the system to be modern. I want it to be able to just change things as I need. I've got so many problems that I see in my business that I want to solve. I want to solve them all. I want to be able to create new features quickly, get out there, be scalable, board on a whole bunch of customers and not worry if the system's going to take strain. I want the system to look sexy. And I foresee there's a lot of money in this. There's a lot of opportunity here. Now, you quickly scrambling and writing everything that you hear Bob say on your little napkin or scrunched up piece of paper, because here's an opportunity. You get to rewrite a new system. You get to employ all the cool things that you've learned. So you come back to Bob, armed with understanding of every single thing he's frustrated with, the things that the old development team has let him down with, and the knowledge of the industry standards. You really start flexing. And you start to say, we're going to use microservices. Ditch that monolith. We've got microservices for you. Kubernetes, that's the industry standard. You didn't know something had failed. The system's going to tell you that something's gone wrong. We're going to create you automated unit tests, automated tests, UI tests. It's going to test the system like a user. Actually click on the physical buttons. If we've broken something, it's going to tell you. We're going to create you an event-driven architecture. I mean, remember that time where a background job happened and you didn't even know that it failed and there was a network drop that caused it? This item's going to sit in a queue. And that means when the network comes back, the process is able to pick it up from the queue. The item doesn't disappear from the queue. It stays there. It's resilient. It's strong. It's scalable. It's decoupled. Data, you know it. We want to enable you with that. We're going to, any form of data you have, we're going to push it through these ETL pipelines. We're going to push it into a data lake. And from there, you can employ data scientists in the future, and they can look at your data from there. We're going to organize it in a way that we can format it and put it in a data warehouse. We're going to give you tooling that enables you to look at your own data, to be able to say, I want to see this, I don't want to see this, without the need of a developer. Remember, you've got this old feeling system, single page application, none of the server rendered nonsense. We're going to create you a modern front end framework, and only the data that needs to go across are the API calls, the JSON data. It's going to be lightning blazing fast. At this point, Bob's eyes light up, and all he sees is dollar bills, because every concern that he's had, every problem he's faced, you've promised him with future-facing modern technology. You sound like you know what you're doing, and he is excited, and so are you. 18 months go by. You, as a developer and as a development team, you're tired, you're frustrated. Bob is angry. This time he's angry with you. His trust has faded. You're sitting with a system that looks like this. It's slow, full of errors, over budget, and every feature just takes longer. The only difference from the old system to the new is it looks modern. Everything else, Bob has the exact same pains on a high level. This time, though, got no legacy code to blame. You had a clean slate. Big bang rewrite. You had every opportunity to build this thing right. You followed all the industry standards. You didn't pick some proprietary thing there. You went for the big names, the popular things. Right now, you feel like you need a much bigger team and a much more experienced team, because some of the team that you have and the people that you've employed, they are struggling with the system as it's been built. What went wrong? I blame Netflix. Netflix is the reason I write rubbish code. Netflix is the reason why my system can't scale, and why I'm sitting here giving the CEO features late, why I'm over budget. Now, let me explain. First, let's provide some context. Netflix has thousands of developers. I mean, just think about that for a while. The biggest team that I've managed was in the 20s. Thousands. I can't even wrap my head around hundreds, let alone thousands. They work at a global scale. Hundreds of daily production releases. Hundreds. And I mean, imagine the coordination that needs to happen. Hundreds of microservices. Hundreds of millions of subscribers who stream videos. It's not just a request, it's actual streaming. They've got a thing that I'm sure you've heard of in the industry called Chaos Monkey, where they, in production, switch off. Chaos Monkey will cause chaos in production, switching off VMs, containers, just to test the resilience. Does it still run? Does it still work? And I mean, this is brilliant. You don't even know while you're streaming your movie that a whole bunch of things in the background are getting killed and a whole bunch of redundancies getting kicked in. From an engineering point of view, this is massive. Not just Netflix. There are many others as well. But this is massive. And so we sitting over here, building our little custom Excel importer that is used by maybe 4 people. And we go to these conferences and we read these articles and we sold this high life of development. It's a real thing. We see all the cool kids, what they are using, the tools they're using, and what they're building. And we see the cutting edge stuff. And suddenly we feel like we're working with archaic technology. That might not even be true. We might be fairly modern ourselves, but we're looking over the horizon to what others are doing, and we feel like we're outdated, we're behind, we're catching this trend that's moving fast. And you have to realize this is a mindset issue. Our mindset has created these failed projects. We're looking at what's possible. We're comparing ourselves. We're feeling insignificant. The word insignificant is important because our efforts and our tech stack and our work feels insignificant when you compare it to these massive massive industries and these massive companies, but you forget where they came from. You forget the context at which they played. You don't just write a system like Netflix with a team of 7 developers. So what is the art of subtraction? We start on the left, right? We create this dream on the left over here, where either through Bob, the CEO, or ourselves, and we think that's what we're going to build. And we start building, and eventually it becomes a little bit out of reach. We're over budget, it's late, it's overly complex. And so we end up in the middle actually delivering, only to realize what we actually need is just to get over this ramp. It's just to get over the obstacle. That is our goal. The user only needed to get over the obstacle. We thought the obstacles might be huge. What if the obstacle is the Burj Khalifa? What if the obstacle is the moon? What if the obstacle is, and we start to just escalate what we have to build. In the end, what does the user have? What does the customer have? He's got a bicycle. He already has a bicycle. You don't have to build him one. He's got one. So all we're building is a ramp. And a ramp is the quickest way to value. That is the art of subtraction, is understanding that we find ourselves here with our dream and we're building across this way. So we start on the left and we start to tend more towards the right. And unfortunately, by the time we realize that this obstacle doesn't grow, that the only obstacle we actually have to overcome is this small little thing that we could have just built a bike and would have been okay, we've already built in a whole bunch of this and we're sitting somewhere in the middle. The art of subtraction takes discipline. It takes pragmatism. You have to make unpopular decisions. Let me tell you this. Be willing, young aspiring software architects, please be pragmatic. Be willing to be unpopular. Look at what you have. Don't look at the dreamy future. Look at what you have. Listen to the future. It's critical to listen to where this thing could go and to make decisions that can align yourself towards a goal and not create problems when you head towards that goal. Start with what the user needs. This is difficult in a world that makes a lot of noise. I want you to just pause for a moment. When you hear the word, or let me say, when you use the word iterate, I'm going to iterate. Careful, careful. Because what happens in reality, we aim for this and we say we'll iterate. But we're not iterating from earliest point to value. We're iterating and saying, okay, well, I don't need that star. I don't need this. I might be able to just get away with some plastic fins here. Maybe we don't need the cone. But what we're building is already complex. We've already got in our heads that we need a rocket. That is not what we need to do as architects. We need to understand we may end up with a rocket. Our obstacle, while seemingly small, could potentially one day be the moon, in which case we do need a rocket. However, what is our obstacle now? Iterate means not from the dream, let's iterate to get to the dream. It says, I know where the dream is. Now let me see what the user actually needs. Get to the earliest point of value with what, importantly, the user has, and then aim yourself that way and iterate to the left. That is the art of subtraction. That is what will get your business scaling. Some people are building rocket ships, actual rocket ships. I could build a ramp, but I actually want to get some of that complex action, that stuff that I read about, the stuff that I hear about in the conferences. I want to build a rocket. There are companies building rockets. Let me build a rocket too. Now let's talk about some big companies. Firstly, Stack Overflow. Stack Overflow was huge. If you were a developer, you probably Googled, skipped every other link until you saw Stack Overflow. If you didn't, you're probably lying. No, Stack Overflow was huge. It was popular. It just worked. And if you were in the .NET community, this guy was a legend. He was, to you youngsters, this guy, John Skeet, was the ChatGPT before ChatGPT existed. Now you might think Stack Overflow, which handled about 500 million page views in a month, it probably had some exotic or some elaborate back-end architecture. I mean, that is what I thought as well. But if you look it up, this is what they ran on. They just deployed the entire Stack Overflow onto a monolithic server. The API, the whole server, was one monolith, single deployment, reaching out to SQL Server, Microsoft SQL, a single, not sharded, not distributed, a single SQL Server database with a Redis cache for optimizations and Elasticsearch. And Elasticsearch wasn't even that elaborate either. It was literally just calling the search and getting the results. That's it. Now, stop and pause here for a moment. And you say to yourself, I want to build something huge. Stack Overflow was huge. It's kind of died now, but it was huge. It was huge in its simplicity. Recognize that. Because we got to start reversing the script that complexity means big. Complexity starts with simplicity. You don't get complex off the bat. You can. It has worked sometimes, but almost certainly struggle far more if you start complex. What about something else? Instagram, right? That's pretty big, right? This is pretty impressive. 3 devs, took them 6 months, and they scaled it from 0 to 14 million active users. 14 million. I mean, that is insane. In 6 months, just 3 devs. And how did they do it? They were very explicit about some of the decisions. They had 3 key principles they worked with. Keep it simple. Just stop here for a moment. You want to build Instagram. Is your system bigger than Instagram? Probably not, right? They started with simplicity. The art of subtraction. Start simple. Reliable tick. I'm sure it was tempting to go for the new stuff, the flashy things. They went with something they knew. In their case, it was Python with Django. They were familiar with it. It had proven itself. It stood the test of time. They stuck with what they know works. And they focused on photo sharing. And this is important as well, because we sometimes get caught up, and as we start to think things through, okay, there's likes and there's shares and there's recommendation systems, and before you know it, you're building all the things around the fringe. Good architecture is to be aggressive with your focus. What is that ramp that you got to build? What is that core piece? It's photo sharing. Let's build photo sharing. Forget the stuff around the sites. That will come. That will come. But let's get in the market with what adds value. Let's get there quickly, through simplicity, through what we know well. Let's take a look at eBay. They developed eBay in 3 days, over a 3-day weekend, using Perl script. And when they realized they've got something, developed it into a massive C++ monolith, evolved into that. And finally, when they started to hit problems with C++ and limitations, they moved it over into a Java-based architecture and had split it into sort of 3 main applications, independent applications. And finally, now what we see in eBay is a cloud-native microservice architecture. Now, what's interesting about the cloud-native microservice architecture, and I would recommend go looking up Randy Shoup, who's got he presents at some of the architectural conferences, talking through the whole journey of eBay. But what's interesting there is he notes that they captured the market quickly by getting out and seeing if there's value. They capture the market. Then you grow and you scale. And only when you have a problem. They employed the Strangler Fig pattern for the microservices. We're going to continue with our monolith until there's an area that we see has such high traffic that it's becoming a problem. Then we peel it off, create its own microservice from there, and then we carry on from there. Because this is the art of subtraction. Do I really need to start with a microservice? If you told me you're building eBay, and if you ask many others you're building eBay, the first thing we think is e-commerce. You've got to have microservices, you've got to have scaling, you've got to. And These days, yes, there's a lot more examples to go by, and we can learn from some of the examples that have failed and not. But let's take a look at what microservices do. At the beginning, where you know the least, you start to draw boundaries and say, this is where I'm going to shift this out. I'm going to scale it differently. I'm going to have a different team working on it. You start to make assumptions when you know the least. Sometimes your assumptions may be right, but often you were wrong. Drawing those boundaries up front, you're going to pay the price of that boundary all the time unless you revert back. Going the other way around and saying, we don't need it right now. If this is success, we're going to have to need it, is plan for the future, build for the present. Get it out now, and then pay the price only if and when you need it. I'd like to share some personal stories as well. As I'm telling the story, I'm going to give some info about what I was presented when I had this opportunity. And I want you to see the decisions that I made and the pitfalls I fell into, and see if you can pick up on certain things. Listen carefully and test yourself. Are you able to apply the art of subtraction? The year is 2014. I was working the fields when I was presented the opportunity of working as a software architect. Now, this excited me. Finally, I get to cut my teeth with something proper, something that I've been dreaming of, planning for, studying for, doing a lot of hard work for. And here was my opportunity. I was told we need to go from a VB.NET world into a modern C# world, that the stack that we're using, the projects that we've built are outdated, and we need a way across teams to move it across to C#. First thing is, there were many different types of projects, but I'm just going to focus on the desktop one. And we were about 3 teams of about 12 developers. And most of the systems were written in VB.NET and specifically Windows Forms. And if you've known Windows Forms, it's fairly outdated. It's fairly old. It looks old. The code, simple, flat, procedural. Code behind was a click of a button. It does some stuff and done. There weren't really any layers, any abstractions. All the utilities that were used in all the different projects, the helper methods, whatever you want to call them, helper functions, they were all copied and pasted, and some bugs were fixed. Some had bugs and some bugs had not been fixed in projects. There were no unit tests, and this is the landscape that I was presented. I want you to put your architectural hat on. Just think about this. Now, the requirement was that I was given when I was employed is help us port to C#. We want to move our Windows Forms to WPF. We want modules to be dynamic, so we can build various models and modules and swap them in and swap them out. Someone might pay for a module, someone might not pay for a module, etc. We want to have a better architecture. I suggested let's start with an N-tier architecture at that stage. And something else that was presented to me said, but we cannot use custom packages. And lastly, we need to create some form of shared library, in which case I suggested let's go for a NuGet package. We'll share that and any project can just pull it in and reuse that. So we fixed the bug once, and it's everybody who wants to update will fix it everywhere. Problem solved. I went ahead and I cracked on. I was full of excitement. Finally get to apply everything that I've learned. I was staying up to date all the years with the modern trends, and this was my opportunity to finally do something meaningful as an architect. And I had ported a little project. I had a plan of migration and how we're going to do it. And we sat down in the boardroom with a whole bunch of developers, and I demoed to them what we have and where we're going and how we're going to port this over. Needless to say, it was a failure. The attempt that I had made to get everybody across was a failure. Think about it a little bit. Why did it fail? The answer here might be more in what was not shared than what was shared. Did you pick up on it? I didn't mention the developer competency. These were not developers who were used to C#. They hadn't used WPF. I wanted to use MVVM, which is the recommended way of doing two-way binding. I loved the approach. I loved the idea that we don't have the click behinds. We could swap out user interfaces. There was a competency that I had assumed because I worked with what I knew and what I had, and I actually thought it was attainable, only to realize I didn't take into account what we had. Same as the rocket idea. You've got to take into account, what does the client have? What does the customer have? They've got a bicycle. Let's use the bicycle. Use what you've got. The art of subtraction, you have to be pragmatic. What have we got? Not what is ideal. That failed. What have you got? And in this case, we've got a bunch of developers, good, competent developers, but in a tech stack and a technology that is unfamiliar with what we have. You create this cognitive overload by saying suddenly it's a new language, it's WPF, they've never worked with it before. Now it's model binding. Where's my click behind? I don't understand. So you're bringing all these new things together at once. Should have gone with a phased approach, especially with .NET, because VB.NET and C#, they both compile to intermediate languages. We could have decided to just create a class library in C# and said, all right, certain libraries we're going to port, because you can create one C# class library and one C# VB.NET class library. That way, you phase in the C#, all the new modules, you create C# in their own libraries, and eventually get across. We could have gone to VB.NET WPF first, and there is the option of using good old, only one thing that changes. Get that right, get that down. You got to ask yourself, what was dynamic modularity for? I mean, that created so much complexity for nothing. This one here is probably the second biggest mistake I've made. So the ask was, we need to stay away from custom libraries. Was there a reason for it? Absolutely. They had burned their fingers with an old custom library. They weren't able to upgrade it at some stage. Support ran out and they were stuck. That story led them to say custom libraries are bad. I remember challenging it a little bit. I think the biggest mistake I made was not articulate the cost we would need to pay if we ignore the custom libraries. Because at that stage, WPF had something called Prism, and Prism had all of these features already built in. It's already been tried and tested by many developers out there. So many of those we had to build ourselves. That's time that we pay, issues that we will create, the complexity we add into the solution. Sometimes it's good then to ask the question and reverse it and say, well, if we could look back and say the choice of package that was used, is there a way we can mitigate the risk? Let's go for something that's widely supported, largely used. The likelihood of that running out of support and completely stopping is a lot less. And if it does, there will be alternatives because many people are using it. There was a lot of work we put in to develop something that already existed. Work that should have gone into continuing the project and taking it forward. And lastly, shared utility packages do not work. I've seen this in several companies I've worked for. It starts like this. There are certain projects, especially if you have multiple projects, that have certain features and certain utilities and common functionality that is used over and over. So there's a tendency we have with the principle of dry, don't repeat yourself. Let's not copy paste it in every project. In this instance, the company that I was doing the software architecture for, they had a situation where there was a bug in one of their common functionality, and they had to update that in every project because it was implemented across multiple projects. Now, the ask of moving it out, I moved it to a NuGet package. Initially, I mean, it's a wonderful idea, and the implementation of it becomes a pain. Because what happens is you start to actually create dependencies you're not aware of. Now everything uses some form of serializer or something, and the moment that you swap that out for a different package, different library, your dependency becomes a challenge because you want to use the latest common or utilities library, and suddenly you need to upgrade. But to upgrade, you also need to upgrade your project and your project dependencies, and that just spins up a whole bunch of risk. So now you're updating projects which haven't been changed, which haven't been touched, they're dormant. You wanted a small bug fixed in a utilities class, but with it comes all this new functionality that requires you to upgrade. So there's a tightly coupled dependencies, meaning that you cannot just easily upgrade. The second big mistake that often happens is you start with certain things that are simple, but you say, hang on, there's functionality that's being used over and over. It's not just little helpers, but actual functionality. The moment that gets implemented and it's too heavy, it becomes a problem, because now you want to see what's going on, what's happened. You can't debug easily into a NuGet package. And so now you sit with this issue where you're using common functionality, something's going wrong. It's your responsibility to fix it. It's your package. But you can't just step through the code. And now you've got to start figuring it out and figuring out ways to debug and then make changes. And now you've got to implement in everything and retest everything in all your projects that implement it. It becomes a pain. My suggestion is to have a library or something, or if you want a class library or some place where you can put the common or the shared things. Every project must just pull it in and on its own, let it stay to that project. Let's keep it simple. Let's not create dependencies outside of it. It's going to pay off in the long run. And yes, there might be that one time which was the reason for the move, where there is a bug and you have to update it across all. But let's be honest, the trade-off of that is rather small compared to the complexity and the risk of the tight dependency. If we could climb into the DeLorean, roll back the time, go and help Bob again, how would we do things differently? I think the first thing is asking ourselves the question, does it still add value? And is it in a state that it could take us into the future with a little bit of help? In our case, I believe yes, it does. We need to focus on the things that really stop business. For instance, that background job. We add some resilience. We add some proactive logging, even if it's just for that one case, that if overnight it fails and it's unable to recover, we email Bob and he knows something's gone wrong, and immediately we can address it before half a day is lost again. We also could look at modernizing the system. He's constantly complaining about how it feels old and how it doesn't take him to the future. We just put a facelift on there, a nice some styling, keep the server-rendered HTML. There's absolutely nothing wrong with it, I believe. With the internet these days that people have can look and feel just as modern as single-page applications or the modern front-end frameworks. And it keeps things simpler. It will give the feeling of quality to the customers, but also to Bob, that he's got something that's actually useful. It'll give him that refreshed feeling of the system. Those three things sorted, we've saved ourselves 18 months of a rewrite, and we're in the same spot, just with a better system. In his worldview, the system is modern. But the important thing is to truly understand what will help Bob. How can we keep it simple? How do we add value now? If this becomes a rocket ship, then great. Nothing wrong with Netflix deciding to do microservices or eBay microservices. But that complexity is earned. It's not designed from the start. Don't forget, coding was never meant to be the thing. It was always meant to be the means to the thing. When we make it about coding, what technology we use, what trends we're using, what tools we're using, we're missing the point. Coding enables us to solve real problems. Once we understand that, it makes it easier to have the unpopular decisions, to make decisions that maybe aren't in line with the newest, greatest, latest thing. Everything you don't build is another thing you don't need to maintain, and there's time that opens up to build what really matters. I want to leave you with a quote by Edgar Dijkstra. Simplicity is prerequisite for reliability. Let's reverse that narrative that systems are over budget, always late, and never work correctly. Let's cut through that noise, make good decisions, difficult decisions for things that really matter. And now let's go out there together and let's build exceptional things through simplicity. Thank you for watching.